Okay, today I'll be showing you how to make the basics of a collision engine and a simple transmission. Start with a block, centered. Make sure it's centered. It's better, just better that way. And now we're gonna make it a reasonably sized to fit your engine or whatever. Make it non-collide. This will be basically your engine block. Let's put an anchor on it. Okay. What we'll need is to make the crankshaft by using 2 ball bearings. Let's get rid of mirror mode for now. Okay, now we duplicate it. Now once you put on your bearings on one side, we duplicate it to the other side. Let's move it up. Okay, now we grab another block, duplicate it, and let's connect both of these. Now let's make the transparent. Now if you did it right, it should spin freely. I don't know if you can see that. It's spinning. That will be your crankshaft. So now let's make the pistons. Oops. You don't use piston blocks, you use sliders. Let's make the, let's see. Let's just make it, I don't know, like 0.3. Or we'll see how it fits. Okay. So you center your sliders. Let's make it bigger. You center your sliders. Okay, so since we're making a 4-cylinder, we're gonna space them evenly. Let's see. Let's make it even. Is that even? Yeah, I believe so. Okay. Wait, just checking. Yeah, it's even. Okay. Let's put this. Let's put the bottom slider block on the center of the crank bearings. Now, okay. Now we need to connect the. Now we need to connect the upper slider blocks, the top slider blocks, to the crankshaft. We will use rods for this. Now we attach them to the bottom of the piston like this, like very bottom, and at the center. And now we arrange them like in this sort of. Okay, so to explain real quick, this is basically we're gonna make a 2-stroke engine. So the way that we're gonna phase the crank pins is in a 90-degree order. So you duplicate a rod to the next piston and put it. See how it's like gonna be onto the side, so it's 90 degrees flipped. Now let's do this for the other side as well, for the next piston, I mean. Now let's duplicate this final piston. Oops, it's off center. Okay, so that should work now. So let's see. Well, not work. Okay, so it should work now, but it's not gonna fire. It's not gonna produce any power yet. Okay, so the issue right now that we have is that I believe the rods are too long. So let's shorten them to 0.5. Or let's try 0.6. Let's see how that does. Okay, so now that let's spin the crankshaft, and as you can see, the pistons are moving up and down, creating reciprocating motion to rotary motion. So how do we create power? So to create power, we're gonna have to wait, it's like sort of a glitch. So we're gonna see. I would like to have longer connecting runs, so let's make it a little longer. Let's make it like 1 or something. Okay, that's good. Longer connecting runs. So basically how the glitch works is we're going to attach a block on top of the case, and every time a piston hits the block, it creates like a glitch that bounces the piston back into the crankshaft, and then it creates torque and power. That's basically it. So the way we're going to be doing this glitch is we grab another block. Let's make this 0. Let's make it reasonably sized. 1, yeah, 1 is fine. Make sure it covers the pistons like this, or else it won't work. Like, it has to be very tall, very thick. Let's make it a little wider on the sides. I think that's fine. So, and let's see if this type of configuration will work. Wait, oops, it's welded. Let's move the crankshaft a bit up. That might, well, it could work. It needs to hit inside of this block. Let's make it 0 density. I mean 0 transparency, so you can see better. Let's just move the top block a little higher. Maybe that would work. Well, it depends. There's like a sweet spot where you want the pistons to hit inside, but you don't really know until you try. So, anyways, in order to make this work, we grab 2 hinges. Make them small. Oops. Wait. And make them a little taller than they are wider. So like that. Now let's connect them to the top block. Duplicate on the other side as well. Now we're gonna make them both 0 density. Also, make sure your hinges are oriented this way, or else it won't work as good. And of course, make sure your sliders are oriented up and down, because they go up and down in pistons. Or 0.1 or whatever. Now we're gonna attach this to the casing, and now let's just test see it works. See if it's attached right. Yeah, it seems fine. Okay. So in order to make it have power, what we're gonna do is we're gonna select the block and the pistons. And what we're gonna do is we're gonna do 0 friction, 0 friction, and 100 elasticity, and max out the top. Both elasticity are maxed out basically. Now we're gonna make the top block 0 density, and we'll keep the bottom sliders 1 density. Now it should work now. Let's see. Oops. You know what? I forgot. These. Okay, so the block and the pistons have to be collision on. So let's see that. Okay, wait. Let's make the crankshaft collision off. It was on. And the anchor. So the only thing that should have collision on is the pistons and the block. Okay. Wait. Okay, let's attach. I forgot a step. We need to attach a flywheel. Let's just make it, I don't know, 3. 0.8. Make it 10 density. This will, I guess, make it have inertia. Keep it moving. I mean, it won't work without it, so you have to put it on. Make it, yeah, just leave the collision on. Make it 10 density. I think it's fine. Okay. No, it probably won't work, but let's see. Let's spin this thing. Oh, here we go. It's working. Okay, so we're missing a flywheel. Now, I don't know what the RPM is on this, so we'd have to check. It might be glitching out. I don't know. So in order to check the RPM, rotational. We get a rotational speed sensor. Make it small. Okay. Now we grab a constant number and a division and a number display. Okay. Now we grab the output of the rotational speed sensor. We attach it to the top block of the division. The top node of the division block. And we're gonna attach the constant number to the bottom node, and then attach the output to the input of the number display. And we grab the constant number and we edit the number to 6. That should give us our RPM. Now let's see. Now let's spin this. Let's see what our RPM is. Oh, that's not bad. It's around 4,000. It wants to do 5,000. Okay, not bad for a 4-cylinder. But see how it's freaking dying? So I think we need to put a governor on this, or we could replace the crank bearings. But anyways, we need to put a governor anyways. So I'll teach you how to make a governor. So let's grab a power piston, not the regular piston, or else it will break. Let's make it a little small, wide. Like this. Attach it to the center. Let's make it so it fits the engine block or whatever. Yeah, okay. So that fits the top of the engine block. Now, let's take the top of the power piston. So it's not gonna be welded. So let's lower the power piston so it welds to the bottom hinges. Smooth this up so it doesn't weld against the pistons. So let's see if that works. Okay, so it should do that. And now it won't have any power. So how are we gonna manage RPM and we can idle and throttle it? So what we're gonna do is we're gonna make a little, I guess like a comparison sort of logic gate. Let's grab a vehicle seat, a greater than, what else? A number clamp. What the hell is it? There we go. We'll grab a numerical switch box. Okay. Multiplication. Grab a constant number. Another constant number. Okay. Number display for troubleshooting. Okay, so we're gonna grab the throttle output of this vehicle seat, attach it to the top node of the multiplication block. So grab this constant number, make the number your max RPM. Now we attach this to the bottom of the multiplication block, and we also attach this to the maximum output of the number clamp. Now this will be your idle RPM. Let's make it 700. We'll attach to the minimum input value for the number clamp. Now we attach the multiplication block output node to the input of the number clamp. Let's do that. Okay. Now let's attach this output value to the number display. You don't have to do this step. Just this is just to make sure everything works. You can see the number you're outputting for the throttle. Anyways, we attach this number clamp to the top input node of the greater than. Never mind. The bottom node, excuse me. And then we get the previous RPM logic, get the output node of the division block attached to the top node, and then we grab the Boolean node, attach it to the numerical switch box, and we make the on value 0.5. So, and then we attach this to the position of the piston. So basically, when we sit on the vehicle seat and press W, the piston should go down and throttle the pistons. I mean the top, this block here should go down and throttle the pistons, make power. So let's test that out real quick. Let's spin this. Okay. So the reason that it's not working is because we have a negative number. It depends on the way you Anyways, since we don't want to make one way spin, we only want one way to spin. Let's make it so that doesn't allow counterclockwise rotation with the crankshaft. Let's grab a less than, duplicate this constant number. Let's grab an OR block, OR gate, Now, make sure this constant number is 0. Put this in the second value. Grab your RPM output from the division block you previously made. Now attach both less than and greater than nodes to the OR. Remove your previous numerical switch box node. And now we grab the OR gate output node and attach it to the numerical switch box. That should prevent counterclockwise rotation. As you can see, it's not getting powered. The RPM is going down. Now if we rotate it this way, it should power. As you can see, the top block is going up and down, managing our RPM. Our throttle is set at 700. Now if we max it out to 4,000, it should get, as you can see, 4,000 RPM. And now let's let it coast. Okay, so now it's coasting. Now once it reaches 700 RPM, it should go back down to idle and keep it there. There you go. Oh, I forgot to mention that if your rotational speed sensor is oriented the wrong way, then clockwise should be this way, right? But if it's rotated the wrong way, so maybe you point it outwards, clockwise will now be this way, which is actually counterclockwise. You don't want that. Yeah, it's spinning this way now. When we want it to spin this way. But as you can see, it's not getting power this way. It should really be spinning this way. So make sure your rotational speed sensor is oriented backwards. Should have specified that previously. So, how you tune the engine is, the most easiest way is just to adjust the density. So, higher density is more force, more power. Lower density means less power, less force. Usually you don't want to make it that high density because it just gets crazy and you break stuff. I usually just keep it at 1. And for torque, if you want more like a diesel engine or whatever, you want pull heavy things, you increase your stroke, and that increases your leverage, which gives you more torque capacity for the same force, but also means it's harder to rev higher. So there's a drawback there. What else? But if you want like a not so much torque, just want to rev your engine, just lower the stroke. Also, if you adjust the stroke, you have to adjust the way your top block is how high it is. Because if you have like smaller stroke, that means your piston won't hit as high. So make sure you count for that. Okay, so to make the transmission is actually pretty simple compared to the engine. So what we want to do is you want to grab a cylinder, attach it to the end of the flywheel. Let's make it just one. Let's make the flywheel collision off. Let's make the cylinder 10 density, 0 elasticity, 0, 100 friction, and then we duplicate it and so we want it to be kind of 90 degrees, and now we attach it to the side. Let me make it so the hitbox is 1 on both sides. Okay, now it's like this. Now we just move it. Okay, well, it depends on what we want. So we're gonna make, I guess, a 2-speed transmission. So let's get a power piston, and we're gonna resize it to 0.2. No, we need to make it so that this cylinder can rotate on its own axis. So let's duplicate this previous ball bearing, as you can see. Or you're grabbing the one, it doesn't matter. And let's make it so that both sides are connected. Let's connect. Let's make another block so that the engine block is connected to the transmission. This will be our transmission casing, I guess. Now, let's move this cylinder to where the power piston top block is connected to. Wait, let me make it so that make sure it's welded. So this is a ball bearing. This is also a ball bearing, but the middle is a power piston, and this will connect to this. So let's see. It should be okay. Yeah, it should do that. So make sure it does that. Well, let's make sure that the engine works. Now let's see if this spins. Yes, it spins. Okay, that's good. So to make a 2-speed transmission, let's just make a numerical switch box. Let's attach it to the position input. Let's get a key bind. On and off. Let's make it 1. Okay. So off will be, let's put it at 0.1, and on will be 0.2. Okay, let's duplicate this RPM logic so we can see the output shaft of the transmission. Or RPM, I should do, because transmissions they change your torque in RPM. So let's see how this does. So if it's a reduction, then if the engine is spinning like, I don't know, like 700, then the transmission output is gonna spin way less. Let's see what this is spinning at. Okay, so wait, it's spinning the wrong way. It should spin clockwise. There we go. Clockwise is positive. Okay, let's see if it's working. Okay, so we have an issue. Let me show you. So we don't want it to be perfectly aligned like this. We actually want this cylinder to be phasing a little bit by like 0.2, and that'll just help it stick and transmit torque like way better. So let's see if that helps. Make sure it spins clockwise. Okay. Wait, something's wrong. Oops. Make sure it's centered. Yeah, if it's not centered, it's gonna be wobbly. You don't want that. Anyways, it should be phasing by 0.2, I believe. Let me check again. Is that 0.2? Yeah. Okay, that's fine. Let's see what our ratio is. Looks to be pretty low. Yeah. So as you can see, our ratio is 700 to 160-ish. 150-ish? Yeah, around there. And now, if we press 1, it should change it, so the RPM should be higher. There we go, now it's around 300. Now, if we attach that to an axle, that means we can change our speed and torque. Basically how this works, let me show you. So this is first speed. So the closer it is to the center of this cylinder, the more torque you get, but the slower you are. But once you move it more outward, the less torque you get, but the more speed you get. This is the simplest transmission you can really make. Nothing much else to it. So now let's just make a demonstration car to show you how it works. So, okay, let's make it thin. Make it non-collide. Now we're gonna attach a axle. Yeah, okay. So we're gonna attach a cylinder to this part, not this. Let's center it, chord 0 for X. Let's move this gear out of the way. Now let's make it, I don't know, let's make it 3 wide. No, 5. Okay, good. Let's make it non-collide so that it doesn't interfere with our gears. Let's make the wheels. Just make them black for him, so it'll make more sense. 0.5. Okay, now let's make the front wheels. Let's move this out of the way, except for the vehicle seals from the back. Detach it, actually. Let's make it. No, we can leave it. Okay, now what we want to do is, let's duplicate this. And let's duplicate a ball bearing. Let's make it a little wider. So just move the ball bearing to the side, and let's mirror it. Okay, now let's see if that does anything. Wait, something's wrong. Okay, let's see. First of all, this needs to be, the wheels need to be collided. Okay, the front part isn't welded, so let's weld that. Okay. Whoops. Let's see. Okay, so the transmission gear is welded to this thing. I'll just move it out of the way. That should do it. Okay. Now, if we just give it a tug, it should. I think it's doing something. Oh, okay. We're moving the wrong. Our transmission is the wrong orientation. So, let me show you. The engine wants to spin this way. So when it's spinning this way, the wheels want to go this way, right? So we want to do this way. So the way our transmission is working is that the engine's spinning this way, but our gears on this side is on the right side. So that means that the wheel is gonna go this way, which we don't want. We want the wheel to go this way, not reverse. So let me show you again. See how it's the gears on the right side? You want to reverse it on the left side. So let's just make the numbers negative. Put a minus sign. Now that should flip the. Wait, let me make sure your power piston block lower limit is allowed to have negative numbers. Now let me see. Make sure it's negative, not positive. Okay. So now it's on the left side. Now if we push it, it should start on its own. Now we have throttle, and now let's change the gear. Oops. Now we're going faster. Let's try it one more time. Now I won't be showing how to make steering in this video. That'll be a separate video on suspension. But now we're tugging it. Now if we press W, it goes faster. And if we don't press W, it coasts. See how the speed is going now? Now when we press W, it's going faster. Now that's the max speed for that gear ratio. Now if we want go faster, let's upshift. And now we're going faster with the same RPM. But we have less torque, so. But yeah, that's how you make a simple engine and transmission.